Got my cue, Mr. President.
Okay, you're on.
I think I'm on. I think we should say, hello, everybody. With that young East Indian UCSB grad student Friday talk behind us, in front of a full house, I might add, and a world-renowned scientist coming to town October 3rd. This is the Santa Barbara Astronomical Union, proudly presenting our weekly 1-hour vlog podcast, the SBAU Astro Hour. Number 237 for September 8th to the 14th, 2025, into our 5th year of cruising the cosmos, exploring the universe, Carl Sagan style, 5, 6, 7 topics at a time. And I'm your host, Ron Heron, former radio guy, now happy-go-lucky astro freak, ready to introduce you to my friends who will take over here in a minute. And we're going to confront these subjects this week, ladies and gentlemen. The moon filled up. It's called the corn moon, technically, but really because it's closest to the equinox, it's the harvest moon. Star Fomalhaut.
No, not this one.
It's the other way around.
Yeah.
What's the other way? Well, we'll talk about it, gentlemen.
Yeah, we'll talk about it.
I read your talking points, Mr. Prez. Fomalhaut. I hope I pronounced that right. I believe it's close. The star standing brightly, southern sky later this week. Something about a co-orbital motion of small bodies relative to each other, a small one to a larger body. It's called horseshoe orbits, and there's some asteroids that have those orbits around Earth. And then there are tadpole orbits. Tonight, the Swan Nebula M17 opens its gorgeous wings.
Yay.
Yeah, can galaxies become unstable? Oh my God, apparently so. It's called fire hose instability. And rogue planets, microlensing, the Webb is spotting a new young brown dwarf. I wanted to share this with you real quick. It shouldn't take long. New York Times says this morning, zodiac signs were originally based on our view of the stars from Earth, but over thousands of years, that view has shifted. For example, today, the 8th of September, it's in Virgo, technically, because 2,000 years ago, the constellation Virgo was more or less behind the sun on this date. But the actual constellation behind the sun today is Leo.
Right.
And they went on to say, want to see your astronomically correct zodiac sign? Learn why the signs no longer line up with the constellations they're named after. Must be driving the astrologers crazy. Let's meet the gang.
They're already crazy.
We meet at the beautiful Museum of Natural History. First Friday meetings this Saturday night, coming up, second Saturday star party. And you can join a great club. Let me tell you, meet some great people for just $20. Here's our beloved president and commander, Jerry Wilson.
Good morning, everybody. And good morning, Joyce. And good morning, Calvin. And good morning, Riley.
Good morning, Pat Forgy, your beloved wife.
Yes.
So sweet. Love meeting her and talking to her. Chuck McPartland's also married to a beautiful Pat. Pat McPartland. Chuck's our outreach guy. And he goes everywhere in charge of the events. Here is, let's see, Tom Whittemore joined us, editor of the newsletter, former college professor of science at Westmont, and doggone of Tim Crawford, who is a telescope expert, as far as I'm concerned, resident lens, and having, I guess, his sewer pipes changed this morning or something.
Possible.
You may have to leave us.
His sewer pipes, his house is sewer pipes.
No, it's just we just have a leaking toilet. We're replacing it.
Okay, well, we smell it. I'm sorry. And look who joined us, the president himself of the Theater Organ Society of Santa Barbara, telescope enthusiast, longtime supporter, and now off screen, trying to set up a
upside
two-person.
down.
That's how we like to see you, upside down, hanging from the ceiling, Bruce Murdoch. You seemed almost lost.
All right.
There you go. That's better. Yeah, we like that. You're gonna get it. You're gonna be getting the same laptop that Tim Crawford got for Christmas, so you can go down to 1 unit, my friend.
I'm only using 1 unit right now.
Yeah, everybody, all you ex-engineers and retired physicists were really up in arms Friday night with my guest Ish Call, except for possibly Bruce. You kind of were joining the rest of us armchair guys, weren't you?
I thought Bruce was in the southern hemisphere there.
Well, I
There
was
you
going
are.
to question him. He said, "Well, we just treat this as though we're a fluid." Well, Poisson's equations and fluid dynamics. If it's simple, like what the plumbers use, they treat it like an electrical system. Pipes have resistance. Current flow is equivalent to water flow. Pressure is equivalent to voltage, and you just put it together. As soon as he put up those diagrams where there were wiggly things in there, that means it's not linear.
Well,
And
Tim, why don't
I
you
didn't
ask your plumber later this question?
well, I
Hey,
didn't
Joe.
want to ask him because they were pressed on time, and
Yeah, always. Well,
I-
it sounds like a future topic for the talking points put together by our president, Jerry Wilson, who is now going to bring up our sillies to start the hour. We have science sillies. They're mostly about science and some thought provokers thrown in as well. So without further ado, let's get silly. Put them all in one email. Not sure if you send them from your cell phone or your laptop, but boy, it's great. There they are. The aliens landing, a couple of them. They're UFO,
I like this one.
UAP this thing at the White House. Want to meet Trump? They say, "Take me to your leader." Moments later, the suspicious undocumented aliens were never to be seen or heard from again. That's a new plot for H.G. Wells' War of the Worlds.
Unfortunately, that's not funny.
Yeah.
Well, it
Just a
can't be.
minor point, their drawing of the White House, these windows have a peak over them. It alternates peak, arc, peak, arc.
You're right. I've noticed that too.
Yeah.
It's like the lady that's talking about AI in the video I watched, and she kept calling it Al. Okay, you're gonna have to enlarge that one.
Really washed out. Really washed out.
Well, I can tell you that would be the antique store owner waving goodbye to the car with a magic bottle that somebody just bought from him. And as it's driving away, the back end of the SUV comes up, and maybe we won't be able to see it, but guess who was waving to him goodbye? I guess we're not going to see it.
It's coming.
Ah, there it is. The genie. Goodbye, and thanks.
Yeah.
for
Coming
running.
coming from a lamp in the back of this van or station wagon, someone just
Yeah.
bought.
Yeah, so you have your wish. You're now going to become a Home Depot or an old antique store. Okay, here's the stick figure lady lecturer, and it's headline Cosmology Breaking News. Brand new telescopes are finally powerful enough to read the little labels up next to the stars showing how far away they are, the little telephone numbers Neil deGrasse Tyson talks about.
And that label's a galaxy.
Right.
This one's a galaxy?
And that's a repeat.
Oh,
Is
that
it?
is?
Yeah.
I don't remember it.
No, there was one very similar to it where the skies got so clear you could see the right ascension and declination in the sky.
Oh, it's not me.
Think we got a Bruce feedback again.
We got Bruce
Bruce,
feedback.
I have
Got a
one.
Bruce feedback.
Pull the plug, Bruce. Thank you. Hate to lose you, but you can fix that, I'm sure. Now, the spaceman falling into the black hole, thought to be spaghettified, saying, they say time flies when you're having fun. Well, due to the, what's that word? Dilation of time.
Yeah,
That's
the
right. It slows
dilation.
down, doesn't it? 50 years have just flown by on Earth. Since I started drifting towards this black hole, and I am not having fun.
And Ron, of course, you know what they say.
What?
Time flies like an arrow. Fruit flies like a banana.
Okay, I'm not sure who these two are, brother and sister, dad and
These are just
mom.
a couple of kids playing with their imagination.
Okay. They land on a moonscape somewhere on a distant body of, oh, geez, now what are we going to do? We're supposed to do. I only had enough imagination to get us here out of the box. We all went through that. Okay, here is the couple in a convertible driving past an atomic testing ground. And guess what the mutated giant toad is sitting on at the side of the road?
Yeah,
A
it looks like
tree-sized toadstool. It
Yeah.
says Atomic Laboratories.
Looks like a love canal toad.
Yeah.
Yeah,
You know, the headline earlier about tadpoles.
yeah.
Tadpoles are baby frogs. What are baby
Got
toads
feedback,
like?
feedback.
Feedback from Bruce again. They're
And
called tadpoles also.
do they
Yeah.
look like tadpoles with little? Do they
Yes.
squirrel
Oh,
it,
little tiny, yeah.
but out of the water and
No, they're in the water.
for toads?
Didn't you ever
Yes.
raise them? Didn't you ever raise them, Ron?
No, I never
Every
did.
kid did that.
I just knew frogs came from tadpoles, but I just saw grown. You weren't supposed to touch them, those toads. All right, here is the couple, father and son. It looks like members of the Jedi, seated at night on a Star Wars planetary precipice, looking out at the night sky.
Yeah.
And I'm trying to remember who the villains were in Star Wars. Was that called the Empire?
Yes.
Yeah, they were the Empire.
Just the Empire.
This is the Death Star, and
Right.
these are the Grim Reaper and his son. And
He
see,
says
they
what?
have their scythes.
And read what that says.
Yes, son, they're all magnificent, but that one holds a special place in my heart. Death Star.
And
I
is
didn't
it,
get that at first.
and is it Ceres that has that big round crater on it that looks like this? Or
Yeah, it's in the movie.
The,
No,
the
no,
moon
I-
you're thinking of, Ron, is around Saturn, and it's Mimas.
oh, okay. It's not one of the asteroid or the dwarf planets.
No.
You suppose it's the size of a dwarf planet? Do we have moons the size of dwarf planets?
Yes.
Titan would be, wouldn't it?
Yes.
Ceres is a dwarf planet. It's not a moon.
I know, but it doesn't have that giant round.
No, there is just one moon, I think, that someone said just a moment ago.
Yeah.
That kind
Never
of maybe looks like that.
I'll never forget Mark Hamill going, "We're going in,"
Yeah.
cruising down. Oh, here's the two unwritten rules of life. One and two. They're unwritten. Whether it was a church or there are some churches that post stuff like that, but others, things we don't repeat. Gentlemen, let's talk cosmos. Get me out of this. Good to see you all. There it is.
Yeah.
Now, this is a photograph from several years ago of a partially eclipsed moon.
Mhm.
You can see the red part near the center of the shadow of the Earth, and the bright part has yet to be immersed in it. There was a total eclipse of the moon yesterday, and it was not visible from North America,
Mhm.
at least its totality. And a lot of friends of mine called me up and say, "Where's the best place to see the eclipse?" And I said, "India."
That's right. That's right. Our friend Delhi was.
Yeah.
Because the moon sure was pretty coming up last night. It's beautiful.
Was it really?
Yeah.
Oh my God, it was beautiful.
Now that illusion that the moon is real big when it comes up is a artifact of the fact that we have developed our unconscious brain has developed a number of signal processing algorithms that we're not consciously aware of. And one of them is the fact that your animal brain behind your thoughts, behind your language, thinks that the sky is flat. And so if something's on the horizon, it's far away. If something's directly overhead, it's very close. And that gives you the feeling that it's big or it's little, but it's exactly the same size from your perspective.
Yep.
Okay.
What was the controversy during my headlines between corn moon and harvest moon? Which is which?
This is the corn moon that just happened. The harvest moon is the one in October.
Okay, well,
The
Because
harvest
it's slightly closer to the equinox.
right.
this one is, or the harvest?
No, the next one
But
is.
the next one will be,
The
yeah.
harvest moon is a special label that is applied to the full moon that's closest to at the equinox.
Well, then I misread your talking points, Mr. Prez. I thought you said this one was the closest to the
Nope.
equinox.
No.
He actually mentioned that it wasn't as close.
Oh,
Yeah.
maybe I made was out of wasn't. Okay, got it.
Don't worry about it. I'm not above making typos like that.
These speeches in front of the club, you get your tongue twisted around your eye tooth and you can't see what you're saying.
The thing is that I have makings of a politician. I can't think and talk at the same time.
Well, you're a grand president.
Good thing
All right.
you don't have to
To the
read.
night sky. You want to enlarge that. There we go.
Yeah.
Wow,
Now this is,
that's a web. Oh, Hubble.
Hubble
Really?
and Webb.
Yeah, okay,
Hubble and
okay.
Webb. This is M41, I think, not 42. Or this is the Orion Nebula.
Mhm.
Which is 42.
Yeah, 42. Okay, got it right. And this is look showing the resolution difference. There's a silhouette disk in front of this for Hubble to block out the star. And you look at the shock wave that's going through, that it's traveling through. And this article is about young dwarf stars. For example, Cha H alpha 1, a young brown dwarf. Let's see. Oh, that's right. In this young brown dwarf thing, we of which these are examples, they are very, very rich in. We got a good JWST got a good spectral of these things, not these particular ones, but of one called CHA H alpha 1, which is a very young brown dwarf, and they found a plethora of organic molecules in it, which I should have made a chart of. But it's C2H3, CCH2, CH5, CH3, excuse me, CH4, C2H4, and a whole bunch of other things, which suggests
What is CH?
a carbon.
Carbon and hydrogen.
Oh, okay, okay.
It's like ammonia. The place stinks. And additionally, there's a lot of H2O, CO, and OH. Oh, those are absent from the spectrum. The dust around these stars dominated by large 4-micron size amorphous silicates, that is magnesium silicon dioxide.
Dumb question time. Brown dwarfs we're talking about here, though, aren't we?
Yes.
Are we seeing them, or can you see
Yes.
a brown dwarf? Aren't they smaller than a red giant, a red star, or a dwarf star
Yes.
that are a red dwarf?
Yeah. They may not be smaller, but they're dimmer.
Yeah.
Okay, so how in the
Remember,
world
it's
is the web
bright
that good that
in
it
the
can
sky,
see brown
huh?
dwarfs?
What's
Yeah.
that?
Is the web that good it can see brown dwarfs?
Yes.
It can see the shock wave around the black dwarf.
And it can see the brown dwarf better because it's better in infrared.
Yeah.
And brown dwarfs are not rogue stars, are they? They're orbiting like Jupiter.
No, not necessarily.
Oh, because they all right. So they're the center of their own little whatever you want to call it. It's not a stellar system, would it? If they have planets going around them.
Right.
Interesting.
Then there'd be brown dwarf moons.
And that's the Orion
comments-
Nebula.
Your comments lead us into the two next topics, which was a southern star, Fomolo, that has, and I call it Fomolo because there's a radio show that comes out of McDonald Observatory. It's a little 5-minute thing that they interrupt your radio shows for. Put it on,
Right.
and they always call it the Fomolo Hour. For some reason, I happen to have listened to that one a lot. Go ahead.
Are they referring to Fomalhaut the star?
Yeah.
Yes.
Mhm.
But I pronounced it right. Fomalhaut.
That's how I grew up.
Yeah.
Mouth of the fish.
That's right.
Oh, I didn't know that.
Yeah, fish's mouth.
Amazing.
So it's going to lead in nicely to the Fomolo Hour and to the Rogue Planet thing a little later.
But these are in the big nebula of Orion.
Those brown dwarfs were
Yeah.
that were in the image.
Okay. Inside all that dust and gas that Ishkal was talking about.
Okay. Now this is about 11 o'clock at night tonight. Now the moon is up here next to Neptune and Saturn. This is looking south here. And there's Fomolo. This is about as high as it gets. you can tell from all these arcs, they peak right around here, and Fomolo is going to follow this arc through the evening. So,
It's often called the lonely one because it's the only first magnitude star in that part of the sky.
okay. And
Oh, I forgot the helix was over there.
Mhm.
Helix?
Yeah, it's over there next. The Capricornus right there. It actually we refer to it a lot as a bikini bottom. If you continue the line down at the bottom.
And Tim, one of my favorites is Goose the Crane, because with binoculars, it has these wonderful two, these twos going up, these stars in pairs.
What in the
You
world?
can kind of see it. You can kind of see it in Jerry's figure.
But
To
there's
me,
a
that
big-
always looked more like a giraffe.
Yes, yeah.
if you take these red lines and you add one going down here, then as Chuck puts it at the planetarium show, it's the bikini bottom in the sky.
Oh, that's the
Or it's
one.
supposed to be a goat, but it looks like a boat.
Yes. And here's the Helix Nebula here,
Yeah.
which is a lot like the Dumbbell Nebula.
And that's a piece of my DNA up there, huh?
That's right. There is no RNA nebula, is there?
Nope.
Aha.
Okay.
I'll bet you could form stars to make the whole damn bikini, the upper and the bottom, the lower, the broad. If you wanted to.
So this is a wide field photo
Yeah,
of Fomolo. This is Fomolo here.
yeah.
Fomolo.
Nice yellow orange star down here. But it's a bright star.
That looks like the crane, Jerry.
Yeah, the crane is below
I
it.
think that's the crane. You see those double ups, those stars? They're wonderful in binoculars.
Okay.
Yeah, that's like a hind leg and foreleg of the giraffe at the bottom, and then
Right.
the giraffe's neck going up to me.
And you see that blue star there on the bottom?
Now this is those two stars
No, it's down
Oh,
further.
no, the crane. I think it's the crane here.
down here.
Yeah, it's the crane. So that's
Yeah, you see-
Alnair and Beta Gruis.
Right.
This is Gruss.
And Jerry, if you want to challenge, go back to the other one.
Huh.
This is not a binocular challenge. You see Alpha Gruis down there, that blue guy? There's a galaxy way in the background of that guy. It's really cool. But you got to have a good horizon, you know.
Yeah, that'd be rare for us.
Not here.
Yeah.
But it is there, huh? Behind
Yeah,
the-
that blue star there, Alpha Gruis.
which is in our galaxy.
I think it's called Alnair.
Yeah,
Alnair.
Alnair.
Yeah.
Wow.
That's
There's a
beautiful
line of
shot.
stars there.
That's a beautiful shot.
Yeah.
Yeah.
Let's see, who
Signed
was
off.
this? This is an amateur. No, it's not. These foreign names.
Yeah,
East
wide
Tower.
field, huh? Wide field.
OIR lab at NSF.
Okay.
You know, some of our new planetarium shows, the really good ones,
Uh-huh.
are from NORLab.
Wow.
Oh, okay.
There's a really good one that I played yesterday that we should play before the next meeting, since we sort of have more wiggle room in running over. It's kind of a long one, but it's pretty good.
Wouldn't it be nice to be able to see this many stars on the star party?
Yeah.
So, what was the topic of yesterday's planetarium show?
It was Messengers from Time and Space.
Oh,
And it's done by NOR Labs, but it's about time domain astronomy and also multi-messenger astronomy. And it really was, you could tell it was focused on the Gemini observatories.
okay.
Because they didn't mention our friends at LCO, which they should have for time domain. But
Yeah.
But it also mentions neutrinos and neutrino detectors and
Uh-huh.
the LIGO.
Huh.
But I hadn't seen it before, and I wasn't prepared for it, so I did my usual 20-minute introduction, and then I fired it up, and it was like 29 minutes long.
See, when I look at these things like this for a while, I start seeing things like here's a bow right there,
Yeah,
like a bow
nice
tie.
arch.
Yeah,
Mhm.
yeah. And here's a little S.
I start scratching.
And there's a pentagon here,
Mhm.
like Cephas.
Yeah.
Wow.
It's really nice. You can see the fish, you know?
Yeah.
Okay.
So
Oh,
would it
blue-
be
oh,
fair
blue
to say,
stars.
guys, that the bright stars in that picture are in our spur or our arm, and the rest of them are way still in
Mm.
still in our galaxy, but
Oh, yeah, absolutely.
Well, absolutely, yeah.
Everything you see here,
Those stars are probably just hundreds of light years away, you know?
except possibly that. I don't know what that is. It
Like a
looks
little planetary, maybe.
yeah, it looks
Yeah,
like an
yeah.
extended object.
a little color.
That's nice.
You know, Ronnie, when we go up and when we're in the really dark skies, when you get the sky really crowded with stars like this, it's really difficult to pick out the constellations sometimes.
Bruce, you're really warbling. Yeah.
But you don't get
I
that.
don't. No, never mind.
Bruce, we thought you went out to buy a laptop. You ever join us? We're gonna get you one, my friend. I guess he's still trying.
When I don't when you're unmuted, Bruce, it sounds like you have a blender right next to you that's on.
But you're muted, so it's fine. We don't hear
So
a
this
thing
is
now.
a picture of Fomolo
Oh,
with its ring, Hubble Space Telescope, and they thought they had found a Jupiter-sized exoplanet up here in it about 20 years ago, but it disappeared, and they made a model of the dynamics of what a dust cloud would do if it were in that position, and they've decided that that's probably what that was an expanding dust cloud. And this is from the model. These are not photographs. This is the dust cloud expanding and going completely away in 10 years, merging with the rest of the ring around Fomolo. So Fomolo is a young star in an early stage. It's still got a planetary ring around the protostar.
Okay.
Is that what the ring is? It's going to become planets?
It's a dust ring. Either it's a protoplanetary disk that just decided not to be planets, or it's in an early stage of developing planets.
And they figured this was an impact that caused this dust cloud. So two planetesimals that collided.
Yeah.
And became a ring.
No, and became this dust cloud, this little bit.
Yeah. There's a lot of debris in this ring. Two planetesimals smashing together wouldn't have done it.
Wow.
So this in your telescope, this is about 13 seconds of an arc.
Wow.
And when amateurs here on Earth take pictures with our telescopes, we're lucky if we get a star that's about 2 to 3 seconds of an arc across in diameter. So this is fairly high resolution, as you might expect from a telescope in space. What is it, a 92-inch telescope is Hubble?
84?
84.
94? 94?
94 maybe? Okay.
Yeah.
Somewhere up there.
But no exoplanets.
Not that we know of.
No, but they're hoping. They'll keep looking. There's a lot of things to look at in here and characterize.
And you can see they had to blot out the star. It's so bright. So they've
Yeah.
got an occulting disk in there.
Okay. Now we're going to go to something that's going to treat your imagination very trickily here. Very tricky.
Ooh.
And that is horseshoe-shaped orbits.
Horseshoe-shaped.
Now this is a picture of the sun, the Earth, and the moon, and the Lagrange points around these two bodies, L3, L1, L2, L5, and L4. And these are points at which the gravitational pull from the sun and from the Earth are equal. Not equal and opposite, not equal in the same direction, but they just happen to be magnitude equal, but vector not equal. So, and they're useful things. If we had a cloud of asteroids around us like Jupiter does, we would have asteroids orbiting this L4 point and the L5 point, and I think they're called Trojan asteroids. Is that right? Yeah.
Yep.
Okay. And the L2 point out here is beyond the moon. And this is where we parked the James Webb Space Telescope. Now at this place, we have a point that is along, is the only point where the two vectors for gravity for the sun and the earth are equal and opposite. So if you put something here, it would not feel the gravitation of either one of them, sort of. But if it's slightly drifted off, then it would feel one dominating and it would go that way. So this is a non-stable point. It's like balancing a pencil on its point.
So we don't have any telescopes out there, or
Not that I know of. I don't think that's a useful point.
okay.
So, but these lines here are contour maps about the gravitational field that an object placed anywhere would feel. So you can get them to orbit in a certain way that, for example, the James Webb Space Telescope is actually orbiting the L2 point. And the reason it was put here is because they want to keep the James Webb Telescope facing the Earth and have the Earth in the way of the sun, not to block it completely, but so that they can communicate well with the Earth, a clear path. But they want it to fly in formation with the Earth around the sun. But it's in an orbit that's farther out, so it's going to slowly fall behind the Earth because it's going to be moving its higher energy orbit, but it's a slower orbit. So, but at the L2 point, the Earth's and the moon give it a little tug that keeps it up with the Earth. So wherever the Earth is in its orbit, this L2 point will follow around too. And so that keeps it flying in formation with the Earth. So it never gets a big distance between the Earth. So it's always in good communication with us. It never can end up on the other side of the sun, for example, if it were in its own orbit.
Mr. President, is it my understanding that it's about 4 times the distance of the moon out there?
That's about right. I think this is not quite to scale.
Well, I know that, but I understand the million miles.
Right. Yeah. The moon is 250,000 miles, and the L2 point's about 1,000,000 miles. So it's
How
about
L1? Is it also 1,000,000 miles? L1?
I don't know. It's an easy thing to figure out if I have a pencil and paper, but it's not, I don't recall it. So this orbit here, A, B, C, D, E, that's an orbit that's possible if there's something, say.
Oh, I didn't realize that's where it goes.
Say this is say there's an Agena B second stage rocket that was used to put Apollo up, and it was just discarded out here in space, but it actually wandered into an orbit like following these contour lines of equal gravity. Then it will be in this orbit, which is a horseshoe orbit.
Wow.
It actually turns around and goes the other direction?
If you hold the Earth steady,
right,
okay, and look at it from above, that's what would happen. But it's actually orbiting the sun.
Right. Then so as Chuck just said, if we look at this in real time, what you'll see is the sun here, and then you'll see the Earth going around the sun in this orbit, and you'll see all these contour lines going around locked to the Earth like that. And so this orbit here rotates around with the Earth as it rotates around, because this is a combination equal contour lines of the Earth-Sun system. But if you stop, and so that's if you're looking at the Earth, hovering right above the Earth, you would see this orbit this way. But if you're looking down on the sun only, you'd see this going around, and you'd see this going around too, but its relationship to the Earth would change. And the example I gave of a second stage rocket for the Apollo program, that did happen. It came back close to the Earth after about 40 years, and they were trying to figure out what it was, and they got a spectra of the object because they thought it was a captured asteroid, but it had the same spectra as a white paint that NASA used in the 60s to paint their Agena second stage rocket boosters with. So they worked backwards and they decided it was in a horseshoe orbit around the Earth-Sun system.
Agena was the name of that rocket, not Saturn. You're not talking about
The
11.
upper stage.
Oh, the
Yeah.
upper stage is not Saturn.
No, it's the second stage was an Agena booster.
Oh, we're talking about Apollo 11, right?
We're talking about the Apollo program.
Apollo program.
That's not a specific Apollo. I don't remember which Apollo did it, but one of the Apollos was the second stage, eventually caught back up with the Earth. And we get asteroids in these orbits that come near the Earth and back. They're not going to hit the Earth unless they get disturbed somehow.
Wow.
Then also you can have a very thin horseshoe orbit. I don't know of an example of something like this, but this is the Earth and Moon. This is the L2, L1 point, the L5, L3, and L4. And it is possible to get an orbit that has a very thin horseshoe shape to it.
Wow.
So these are
Those are horseshoes.
this is a still frame from a video that shows it going. It shows it how it moves, and I'm going to try and see if I have that listed.
So this is your tadpole, Ron.
Yeah,
Yeah.
that's what I was
But
about
so
to say.
far,
Bruce, are you back with us? Okay, you got to mute yourself. That's
He
sad.
is muted.
Sorry
I muted him.
Yeah.
He can unmute as he wishes.
Well, then we get our repeat, our, what do they call it?
Let's see here. Just bear with me a moment. Oh, yeah, okay. Yeah.
It's like Bruce bailed out at 20,000 feet. Got to get him a little laptop among his others.
I've always wondered if that was two microphones or one, kind of feedbacking on itself. I can't figure that out.
And it's also, it might be there's a delay.
Yeah, there's probably a delay involved.
Yeah.
Well,
Oh.
the picture is a cell phone, though, right? Right now we're seeing that's how wide cell phone screens are.
I think so.
Yeah. The sound goes up.
That name there, I think, is his cell phone name.
Okay.
Ooh, look at this.
This is a horseshoe orbit and here's the Earth.
Wow.
There's the sun.
The Earth is nervous.
Yeah. It's in an elliptic orbit.
Okay, but it doesn't just stop and go back, retrace the route it just took. It still goes by the Earth, doesn't it?
Eventually it will.
This is just, again, if you're holding your position steady here with the Earth.
Yeah. Yeah. If you were actually out of the spaceship looking, you would see only the sun as stable, and you would see the Earth and this object going around the sun.
So it's orbiting our orbit.
In a sense, yes.
It's orbiting the sun, but in an orbit similar to us, but our interactions cause it to do this back and forth motion relative to us.
Okay, it could be a corkscrew or even your DNA helix thing, but it's really a slinky. Remember the slinky toy?
Yeah.
I'm having a hard time grasping it. I'm sorry, gentlemen. I really
Me
am.
too, Ronnie. Me too. Me too. You're not alone.
Okay, well, at least I'm willing to admit it. But we'll catch up.
Okay.
He knows his telescopes at least.
Okay, moving on.
Aha.
M17. Above the teapot, here is the famous Sagittarius, which somehow is an archer, but I'm with Chuck. I like the teapot asterism.
Oh God, yeah.
And here is the spout with the Milky Way being a cloud of steam coming out. This is a very, very rich part of the Milky Way, and our center of our galaxy is right about in here.
And then up above Nunkey there, above where it says Sagittarius, you got a little thing that looks like a teaspoon off to the left.
Oh, yeah.
Yeah,
Right
up
above
there,
Nunkey.
go up a little. Now you got something that looks like a teaspoon. And then down below, right on the bottom edge, you've got a wedge of lemon. Come down further. Right
Oh,
at the
down
bottom.
here?
Yeah, there's your wedge of lemon. So you got a whole tea party there.
Okay.
Which is the Southern Crown.
Yeah, Corona
And
Australis.
is
Well,
the
this-
handle on the left side next to
Yeah.
that spoon? Right, is that
That's
the handle? Okay,
Yeah.
got it.
And there's the lid.
Of course.
You don't.
Does it go upside down and pour out like Ursa Major, the bear?
Half of the year.
Mhm.
Let's see it.
Big Dipper
Oh, no,
sometimes
that-
dips.
Now the star hop that I used for this is just insanely difficult for me. And I used Calus Australis, the lower right-hand star, and then the teapot lid. Those two stars, Calus Australis, lower on the teapot, that star, and then the lower right star,
Farther down.
below it. Okay, that distance from that to the teapot lid, and you go up equidistant, up, but then you have to bisect to get to it. Really, you kind of have to bisect that Calus media and Calus Australis from
So right there.
yeah, you have to kind of bisect it to get to it. It's
Okay.
insanely hard star hop. I always have trouble with it.
Yeah, that's a long distance.
Yeah.
I just type in M17.
I like that. I like that a lot. I'm starting to believe that's the way to go.
Okay, where are we here? Okay, this is a picture of the two nebula. Here's
It's
the
a loon.
Here's the number 2.
Uh-huh.
It's classically called the Omega Nebula because it looks like half of an omega, so it should be the Omega Nebula.
Hmm.
So anyway, and it's quite a nice picture. Let's see if I can give some accreditation. Oh yeah, this is a Hubble Space Telescope. The outline of the. Oh no, this is a ground-based overview of the Omega or Swan Nebula. The outline, the square box there, is the field observed by the NASA Hubble Space Telescope,
Oh,
which is the next picture. We're going to see
Okay.
that close up. And it
Wow.
looks a typical dust cloud. And the it's eroded by very bright starlight coming this way, or actually this way, it looks like. And you see it's just shining down these hills, and it's pushing the lighter dust away.
Hmm.
And this is really burned out relative
Oh,
to your
sorry.
image. Yeah.
Now, one thing that I heard, oh, there you go. There's Bruce's explanation.
Yeah.
He can't turn his unmute or we get feedback.
Yeah.
Well, it's two different. It's the computer and the phone are not synced. You know, I heard when I read up on
Bruce.
M17, I heard it's an emission and star cluster nebula, kind of a star forming region, like M42, like the Orion Nebula, except it's edge on, and I
Yeah.
just don't get how it's edge on. When I look at that, I don't see that.
Yeah. It just may mean it has more depth to it that you can measure with spectra and you know.
Yeah, that would make sense. That would make sense, Chuck.
Similar to how the Ring Nebula they think is shaped the same way as the dumbbell, but you're looking along
Right.
like
Looking
the
down
bottom
the
of
tube, the
hourglass.
pasta tube.
Yeah.
Looking down the pasta tube. That's what I've always heard.
So this is what I would call a pre-star forming nebula. It's going to be. These denser clumps are candidates to become propylids or planetary protoplanetary disks and stars. And as they turn on, then they will be blowing that dust away. But right now there's something else that turned on up here that's blowing this stuff away.
Hmm.
So that white part, is that a specific element?
The blue is oxygen, I think they said.
Okay, there's a bluish tint, that's oxygen, and it's mostly hydrogen. And are there stars in there? Is that a nursery?
Yeah. Yeah, those
Yeah.
are those bright things are stars.
This is a false color, and the colors are assigned to it based on their spectral information. Red represents sulfur, green indicates hydrogen, and blue represents oxygen. And
Wow.
this is from Arizona State University.
Huh.
Would
So,
it be
ingredients of what the Earth is made out of.
And the green was sulfur?
No,
No,
red
red
is
is
sulfur.
Oh, okay.
Green is hydrogen.
Oh, wow.
Blue represents oxygen.
It's not your traditional palette.
Yeah, yeah. Yeah, that certainly isn't.
No, I would have made the hydrogen red.
Yeah.
Oh, stop it.
all right, Bruce? Gods are not with you, Bruce. We're not aligned. M17.
Wow.
Okay. We are learning here.
So you can see there's still a lot going on in the non-bright regions.
Yeah. These are regions where the star formation, where these are clusters of stars that have matured past the dense dust stage, and they are emerging as star clusters with most of the dust blown away, probably blown away by these bright stars. Of course, these bright stars could be a lot closer to it. That's why they look bright. There's a lot of really dark nebula in here, really dense stuff that are candidates to become star forming regions. Now it says, can you read the label that pops up?
Mm.
Little white
Well-
thing? No.
No,
Oh,
right
that-
there.
It
that
says
box?
M18 and M17.
Yeah. So I wasn't aware that, but apparently this is M18 and this is M17 and this part is M18, it looks like.
M18 would have been just barely off on the upper right, I think, in the box.
Yeah, okay, I'll buy that.
They're two separate nebulae with
Yeah.
two different M numbers.
Yeah, because this dark stuff, you know, Messier would have had no idea that this is going on.
Yeah,
Yeah,
the Eagle's 16, right? So 18 is unfamiliar to me.
I don't
18
think.
might be the
oh,
star
E-
cluster.
Yeah,
Okay.
Dumb
Okay, well-
question about the materials, my friends.
not in this picture, no.
I know, but you just mentioned sulfur was the
Yeah.
red, and there's oxygen, and there's a couple of.
Hydrogen.
You never hear about other low elements. They don't ever get lithium.
Oh.
Why doesn't it stack up? Or
Oh, they see it. They see
what?
it.
Lithium
Yeah.
is free.
Lithium is pretty easily destroyed. So,
Is that what it is?
yeah.
Well, carbon is supposed to be one of the most common elements in the universe, and yet I don't see giant clouds of carbon.
It's not fluorescing properly here to show up.
It could
Those
be,
dark patches are likely carbon.
yeah.
And also the stuff that
Hey,
scatters
welcome
the
back.
Pleiades.
Hey, Bruce, what did you do?
I'm not sure. I can't get my cell phone, which I'm using now, to not have the delayed audio.
Well, you did it.
So I've turned off my main computer onto Zoom,
Good.
and it's 100% on my cell phone.
Perfect.
Well, other than looking up your nostrils, this is better. I like.
We're not looking up your nostrils, don't be afraid.
We're not. It's good. It's good.
And it's
Okay.
almost wide enough. Maybe you can weigh in on this question. Where are the other elements in these vast displays of dust and gas?
They're dark. They're not fluorescing.
I'll
Is
look
that what
into
it
that.
is?
Well,
and
there's a
report
number of
back
things
to
that
you.
don't fluoresce. As I was
Yeah.
saying, when you look at the Pleiades, they're all diffuse because you're looking through a cloud of junk to see them.
Reflection nebula.
I'm not sure if it's carbon or what, but then also in our own Milky Way galaxy, we've got streaks of carbon
Okay.
that are blotting out the background.
What we're looking is at the remnants of a nova, right? So everything, including iron.
No.
Iron
Oh,
was.
no,
for the
no, no,
crew.
no, 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 Ron.
We've just switched topics. This is rogue planets, and these are rogue planets identified in the Rho Ophiuchi area down here, if you recognize these streaks of
But
black.
Ronnie was referring to the gas in like the Swan Nebula. No, a lot of that's primordial. It's not results of supernovas.
Hmm.
Could we call rogue planets orphans?
If you want,
We just call them rogue,
That'd be
rogue
a good
planets.
name. They're running around. There's a lot of them, but we never have spotted one yet.
We
Oh, we
spot
spot 'em.
thousands.
We're
that's
spotting
what
them
these
now.
little red circles are.
And so you get them from a web, then not our scopes. We can't see them.
Yeah,
Got it.
this doesn't look like the web.
Really? Well, what's spotting them then? The Hubble?
This could be Hubble, or it just could be a deep image that they've superimposed where they've seen them.
They just
Because
know
Hubble
they're
would
there,
have the diffraction spikes, so this is taken with a refractor.
but are they
Good
actually
point, yeah.
seeing a little dot like a star, or are they
So
just
anyway, these are rogue planets. They're also called free floating planets, FFPs, isolated planetary mass objects. So it is estimated, let's see, rogue planets may originate from planetary systems in which they are formed and later ejected, or they can also form on their own outside a planetary system. The Milky Way alone may have billions to trillions of rogue planets in it. A range of the upcoming Nancy Grace Roman Space Telescope is expected to refine a number. We're expected to get a good number for that, not an estimate. The odds of a rogue planet entering the solar system are much less posing than direct fit. Oh, that's a bad sentence.
yeah, it made no
There's
sense.
none going to come into our planetary system, and there's none going to hit the Earth.
This is Ophiuchus area here. Is that what it was?
Yes.
Okay.
Yeah, looks to me like, yeah.
That's probably Antares down there, that yellow one at the bottom.
Oh, okay.
I thought this one. Could
Yeah,
be.
that one there is probably Antares.
Okay.
And then, right above it there is where Ophiuchus starts up.
Okay.
But they can form inside nebulae just like other star nurseries. Just
Yeah.
not enough there to ignite.
They didn't grab enough.
But they're rolling around the universe, probably with no life on them. There's no Goldilocks zone involved, is there? No, any water is frozen solid probably on them.
Well, their cores could be warm and they could have liquid water oceans under a cold surface. So
So Chuck,
this
Chuck, I
picture
just
is,
want to compliment you. Good eyes. That is Antares. In fact, you can see M4 sandwiched between Antares and that upper star.
that one right
Oh, the
there.
arteries, yeah, that's M4.
Oh, okay.
Look at that.
Now, is the northern and southern claw in this as well?
I
no,
think
they're
it's out
way
of
out of
view.
it.
Out of
Okay.
view.
Yeah, that's obviously a star.
Oh, there's M4 there.
That's 4. I'm surprised that we don't see 6144. That's a pretty nice shot.
This is a wide field shot. It shows 115 potential rogue planets.
Mhm.
So there are two methods of detecting rogue planets: direct imaging and occultation,
And looking for little red
or
circles.
microlensing, excuse me, which is occultation.
It dibs another star that's lit.
Yes.
Or
The-
brightens it with microlensing.
Right, it's a one-time lensing. So you're looking at a star and you're taking pictures every few seconds, and then you get all of a sudden a star goes up in brightness and then returns. That was when a lensing object passed in front of it, and will never do so again.
You're saying gravitational lensing.
Yes.
Yes.
Yes,
So it's just like what happens with those giant galaxies way in the distance,
Yes.
smaller
Mhm.
scale. You can get this. Wow. But you never get the little arcs that look like a smile or the 4 points, the Einstein cross.
You do get that. It's so dim you don't detect it.
no, these are lensing by a point source. There'll only be one flare.
Wow.
For an extended object and the mass was not uniformly distributed, you could get like a cross or a smile or whatever.
So if that
So
happens,
this this is a observation. There was an experiment and they observed 50 million stars in the Milky Way using the 1.8 meter MOA-2 telescope in New Zealand, Mount John Observatory. It's a 1.8 meter telescope, and the 1.3 meter telescope at the University of Warsaw.
MOA is a good acronym for them because MOA is with those big birds in Australia.
Yeah. Right.
Extinct.
get those in crossword puzzles. But if a star dims or brightens, that means it's a rogue rather than one of its own exos.
If it dims or brightens in a certain way for a certain period and it's brief enough, then it's a candidate. They found 474 incidents of microlensing, 10 of which were brief enough to be planets around Jupiter size, with no associated star in the immediate vicinity.
And we sort of mentioned this before a long time ago because this is what the OGLE system that was being worked on by some of the UCSB and
Yes.
LCO people detected.
Huh.
Well,
Something
one
like
study-
optical gravitational lensing experiment.
Mhm. One study suggested a much larger number of up to 100,000 times more rogue planets than actual stars in the Milky Way.
Huh.
So
I wonder what led them to that ratio.
Statistics.
some guy thought of something and he worked out what that means and he came up with that number. Whoops.
Well, you did say that it's not a danger to us, Mr. President, but if one did happen to come through our system, our solar system,
Yeah.
it would only be a danger if it came close to us. It'd be just like another planet that, or like
Yeah,
a Oumuamua passing
It's
through.
like, yeah, exactly like Oumuamua. If it came through, it would be at a high speed. And the chances of it hitting anything are very remote.
Seems to me it could screw with our orbits
Very slightly,
just slightly.
depending how close it came.
Well, you're going to have to do the same topic and the same little orange dots to signify rogue black holes that are everywhere. And I don't know how they're going to find those, but they'd really make them
September-
mark up. What?
In September of 2020, astronomers using microlensing techniques reported the detection of, for the first time, of an Earth mass rogue planet,
Earth mass. Wow.
unbound to any star and free floating in the Milky Way galaxy. So like if you ever saw the movie When Worlds Collide from the early 50s, there were two planets that were rogue planets that came in from outer space, Bronson Alpha and Bronson Beta. And Bronson Alpha hit the Earth square on and destroyed it. And Bronson Beta moved into the Earth's orbit and captured that orbit and became the new Earth.
This
A
is
physically impossible event, because that's not the way you capture things.
that
But
was the early
interesting.
50s. Wow.
52 or 51 or something.
Wow.
Oh no, it was later than that because I was in New York City in 1959, and the marquees on the theaters were showing When Worlds Collide. I remember because I thought, "Ooh, I want to see that."
No monsters or
Oh well, the monsters there were correct monsters. They were inside human behavior.
oh, I see. Gotcha.
Okay, now this is a picture. The two ways of finding it: microlensing, which we just discussed, and direct imaging. This is a cold planetary mass object discovered by WISE. It's marked orange object. It's observed with the Spitzer Space Telescope. It has a temperature of 300 to 350 Kelvin. That's like a warm summer here on Earth.
Yeah.
So they're seeing it in far infrared light, and that is a rogue planet.
It's warm. Might have life.
It's warm.
And it would totally be life based on chemosynthesis, right?
I
If
didn't
it's a
catch
rogue.
that. Chemosynthesis?
Well, Chuck said that if there's no star giving it light,
Oh,
there couldn't be photosynthesis. It'd have to be like that
Oh, I
stuff
get
at
it,
the
yeah.
bottom of the Atlantic that's
yeah,
real
that's wild speculation, but possible.
chemosynthesis.
Yeah. Okay.
How
By the
long?
way,
Go ahead.
0 degrees centigrade is 273.15 degrees
Yeah.
above zero. And so you said it would be between 300 and a bigger number.
350.
300 would be warm. What 350 would be like an oven.
No, 300. Yeah, it would, but 300 is room temperature here on Earth, 72.
Well, 300 is 200 degrees, 225 degrees centigrade, which is fine.
Right. That's right. It has both comfort and discomfort in the same range.
How long does that micro lensing of a star take place? How long? A day or
Oh, no.
like
It's
Chuck
hours.
just
Yeah.
an hour?
Hours.
Okay, so you could see it and you could do a video of it.
Well, in effect, that's what these big telescopes do. Yeah, for
Yeah.
Ogle and stuff like that.
Yeah, the giant one, the Vera Rubin telescope with its giant camera, it's going to just take a video of the stars every day. It's looking for these things. It's looking for anything that moves or flashes.
Well, is this a binary we're looking at here?
Sort of.
What is it?
This is, let's see, this is taken by the Keck Observatory, 2 mass, KOAID, fits used in the program. It's got a long name for that. Let's see, this is, it is a doublet.
Okay. No name on it though.
They're like little failed stars or rogue planets orbiting each other. So
Oh,
it's
really?
a binary rogue planet.
They're not fusing? They're
No,
not emitting light? Or we're just seeing?
they're emitting infrared light.
Okay. Well, maybe you could lead off next week, Mr. President. I think we've run out of time, but what a way to close things out here.
Oh, we have, yeah. That's that's taken by the WISE Observatory or the WISE system. Let's see, it's considered an old IPMO or rogue planet, but its color suggests an old metal poor brown dwarf.
Yeah, and the pair is no, I was going to say the pair is known as wise guys.
Yeah. No, that was the previous image was WISE. This other one is 2 mass done by Keck. This one that's
Right.
currently up there.
Wow. And these rogue exoplanets, or whatever you want to call them, if they don't have moons, they got nothing but bright, starry skies constantly, day and night. No daytime, right?
Yeah.
There you watch 24 hours a day, depending. Well, gents, hate to say it, but let's do it again. It was awesome. In about a week. In fact, Saturday night is Star Party, Saturday afternoon. Join us online for the Zoom planning meeting. And next week, it'll be Monday, September 15th through the 21st, our 238th program. And Alex Filipenko in town on Friday the 3rd. Gentlemen, how exactly do we say farewell astronomically in our club?
Adios.
Hasta Nebula.
Go ahead.